So today we jumped into the wonderful world of exponential functions and really looking at how to apply them. I'm going to go over one example in the flipbook, which will quickly just give you kind of a strategy or technique for finding an exponential function if you're given 2 points. This is going to be a very simple way of kind of what Microsoft Excel does with your Flower Power project and multiple points, but this is kind of what you'll be tested on the test, and this will allow us to take our knowledge of exponential functions to apply them to real-world situations. So in your flipbook, if you go to 3.1.2 at the top, we'll be working in there. So it'll be in the top left, and we're going to be considering exponential form. And our exponential form should be reviewed from Algebra 2. We're going to look at two different letters that will change, a and b, a times b to the x. We learned that a will always be our initial value, or our y-intercept. This is where x equals 0. This is where we begin. And then your b value is your rate of growth. We can just call it the rate of growth. And we looked at that graph earlier. We know that it will be exponential growth when b is greater than 1, and we know it's decay when b is between 0 and 1. Okay. Actually, I probably should be more specific here. There we go. Can't be equal to 0. So that's how we're going to determine if the function is growth, which will be moving away from the asymptote, or if it's decay, and that means it's approaching the asymptote. Okay. So I'm going to go over one example of finding exponential function and looking at finding the a and b. So use the table, or use the data to construct an exponential function, and the form of this will be y equals a times b to the x. Alright, so I'm going to use some data. We'll just make it easy. You call it x and y. 5.5, 10, 15, 2, 24. Some of you guys might already start noticing the pattern just looking at the table, and so on and so forth. So the best way to think about this is we use the method, we started out with substitution, but then we realized that elimination is much easier here. So we're going to choose 2 points. Probably going to want to choose these two and not the 15 and the 0.5, because that's a decimal. So this will just make our life easier. So we have 10 and 1 and 15 and 2. And these both represent xy values. So xy and xy. So if we build our system, our first function will be, actually I'm going to flip the order. I'm going to do 2 equals a times b to the 15th, or 1 equals a times b to the 10th. All I'm doing is substituting in my x and y here and here. Okay, now the reason I need 2 equations is because I have 2 variables, and that's the only way you'll be able to solve. So once we have this set up, we're going to create a proportion, and one of the reasons I put this one on the top is because there's more b's, which is going to make our life easier when we simplify. So the nice thing about writing this as a proportion, and that it's equivalent, is the a's cancel. So we're left with straight division. 2 equals, we have 15 b's up top, 10 on the bottom, we have 5 b's left. Now I have to get b alone. So to get it alone, we're going to take it to the 1/5 power. So So we'll take each side of the 1/5. What ends up happening is these cancel, and we get 2 to the 1/5 power, which comes out to about 1.14. Okay. Now I encourage you to leave that in your calculator because it will allow you to.
Oh yeah, show me how to do that.
So Frank's sitting in with us now. I was just talking about him and how he prepared you so well for exponential growth and decay. So once you find your b, keep that value in your calculator, because otherwise, when you end up plugging it back in to find a, if you round it, you're going to get a different answer. So from here, make your life easy. Plug it into the second equation for b, and you end up getting 1 equals a 1.14 to the 10th, and that ends up being 4, so you get 4a. So a equals 1/4. So your final equation with your initial value would be y equals, we can write it as a decimal, 0.25 times 1.14 to the x. So you can look at this and tell that the stretch factor is 0.25, and then that it's growth because the b value is greater than 1. If you want to write this like the half-life way of thinking about it, your a value will stay the same, and then this value inside will just be 2 to the 1/5 power, 1/5 x, which is the same function, though it looks different. And that 2, for those of you that are able to see it, is from the doubling in the problem with your y values. You're doubling each time, though your x values are increasing by 5. Okay. So either form is appropriate because it's the same thing once you distribute the exponent. So do whatever one makes more sense to you.